Tutultad akulon chichiburit. Ayun, nagre-record na ako. Hi guys, in this video, I will be going over the map function. I'll essentially try to recreate the code that you can see on the screen, and the outline of what I wanted to cover is, first I'll show you and explain to you what syntactic sugar is. Then I'll try to convince you that there is an operation under the hood that's happening inside your Python code, and we'll try to create our custom map function, and we'll try to generalize it, and I'll explain what that means. Alright, and then I end with a question. Okay, that's the content of this video. Let me go ahead and erase everything and also clear the screen to the left. Alright. Okay, the first thing I wanted to explain is syntactic sugar. Syntactic sugar is a design principle that people who create the programming languages use to guide them into creating the program in such a way that it is easy to use by programmers, especially the non-CS people. So the metaphor for this, it's like the sugar. It's like the sugar that you take with the medicine to make taking the medicine a little bit easier. What do we mean? So syntactic sugar version of map. Python does it this way. So what is a map? Let me explain first what a map function is. A map function, the input is a unary function plus an iterator type, and this would mean your lists, any type of compound data structure. So lists, linked lists, arrays, and compound data structures are any data structures that have been const in some way. Please check the previous sample programs to understand what that would mean a little bit deeper. So a map is something that takes as input a unary function plus an iter type. So what would that mean? Let's create our one unary function. Unary function meaning one input, one output. Sabihin natin +1. Def +1 takes as its parameter a single integer n and returns n +1, such that if I try to say +1 of 4, we would expect a value of 5. And of course, we have to print it out because return doesn't automatically mean being printed out the screen. Let's try to interpret our program now. As you can see, we have 5. So our unary function is working. Let us proceed to create our compound data type. Let's just create a list. Sorry, I wrote def. That's not what we want. We want an L, a list. So 1, 2, 3, 4, 5. And let's use Python's map function. And here you can see that it's asking us for a unary function, which conveniently we have already done, and a sequence type, an iter type, which is the L, the compound data type. If we try to, once again, let me write this thrice, because the first one we know will not print anything. The second one, I wanted to show you what it prints out before I allude to the third statement, which is what we want to get. So this is our first print statement. This one, sorry, print +1 and 4, that's the 5 that you can see here. This one doesn't get printed out. These last two statements got printed out, but observe what it printed out. It printed out a map object. This is telling us that, okay, whatever it is that you want to print out, it is inside a wrapper. and you have to unpack it in some way. And in Python, the way to unpack it is through making it a list type. So if I try to make the wrapper a list type, it gets unpacked. If I try to interpret this once again, we get the values that we want. Okay, so here you can see that our input 1 2 3 4 5 was now mapped to 2 3 4 5 6 because of the +1 unary function that we applied to it. Here's something that I wanted to show you, functional property. At least one of the functional properties that are, and I find this the most interesting one. If I try to print L, what do you think will get printed out? Is it the 1 2 3 4 5, which was the original definition of L, or the 2 3 4 5 6, which is the medyo misleading, pero the version of L after the mapping? What do you think? 5 4 3 2 1. Notice that the value of L wasn't muted at all, so it's non-mutable, and this is one of the interesting properties of functional programming here, using recursion and not iteration. I'll explain the difference later on, pero just take note of this. The functional property states that types are not mutable, and that's precisely so because they're functional as a result of a function. If this is the input, this is my output only, and that mapping will hold forever. I cannot really do things in the functional paradigm the way I do it in languages such as, say, Java, where if I try to instantiate a variable and then somewhere along the runtime I want it to have a different value, di ba? We can't do something like that in the functional programming paradigm yet. Okay, so the next thing I wanted to show you, so this is the Syntactic Sugar version. It's now time to look under the hood. How is it implemented in the base level? But before I do that, I need to print L again at least 3 times. Oh, sorry, 3 times. Oh, sige, 4. 4 times. And I'll show you different nuances. This is supposed to print the first element of L. This is supposed to print the rest of the elements of L. And this is supposed to print the head of the rest of the elements of L. And let's try to save that and interpret it once again. What do we have here? Okay, so I will try to create a header here. Okay, OC. I'll try to create a header here that says map demo under the hood. Yan. Save. Try to reinterpret it again. This is the print L. It prints everything, the original one. This is L index 0, the first element. This is the rest of the elements. And if I try to do this, it prints 2 because 2 is the head. 2 is the head of the rest of the elements. Notice that we are trying to read from right to left because that's how stacks operate. And essentially, recursive functions, they have this, again, as you have seen in the previous episode, they have this expansion and collapse. And taking advantage of that recursive property, this is now the time where it's collapsing back. So we read from right to left. It gives us that opportunity to recursively reference the head. So say for example, if I want the rest of the rest, oh sorry, more on that later, pero this is how it works. Okay, so if we are trying, if we know this, how can we create the map function such that it takes advantage of this property, the head and the tail? The head and the tail. Okay, define, let's call it M for simplicity, M, and I want it to have the list and some kind of accumulator. All right, and then sorry, I'm thinking kasi L na to eh. Let's make it original. Siguro LL, yun. It takes as its parameters a list and an accumulator, and then if not LL, which means that's our base case. If we arrive at a point where LL is now empty, then we just return A, and then else we try to return M, but with different arguments now this time. And I'm particularly interested with, at each recursive step, I'm processing the rest of whatever it is that I wasn't able to process yet. And then for A, as in the case of A, I want it to be populated. So a list A needs to be populated. And sorry, we mentioned list, so might as well let us try to define A here. Because we needed an accumulator. It's a place where the things, our answers, get stored. So A, let's populate it with whatever is inside LL, the head of LL, and we can now do stuff with the head, whatever processing we want. Siguro in this case, to keep things simple, we want it to be we want to arrive at a list, an output list where every element in the input got multiplied by 2. Yun, that's simple. So times 2. So if that's the case, let's multiply this by 2 before adding it to our output list. Okay, fair enough. So let's try to remember also that this is a list. So in order for us to add a list to a list, we should also create a list first before adding it to our output list. Okay, let's try to check if this works. So print, we have, or let's call the function first before printing. We know that we need to call M. LL will take as input our original L list. So let's pass our original L list, and our A will have to be this one at line 31. Okay, and of course we know that it won't print anything, so we need to issue a print command. And if we try to, I anticipate that this already works, but let's see if there are errors we need to fix. Okay naman. Our original list is 1, 2, 3, 4, 5. Once we have created this custom map function, we arrive at 2, 4, 6, 8, 10. Every element got multiplied by 2 because that is what we intended to do. Just for transparency, let's try printing the value of A here, just so we know, or just so we can get an idea of how the output accumulator got populated. Ganito siya. So it started with 1, and then 1 times 2, and then it added it to our output list. 2, 4, 2, 4, 6, 2, 4, 6, 8, 2, 4, 6, 8, 10. Cool. Now there is a problem with this, and the problem is, and I think this is the part that got a few people confused when I uploaded this first in the Moodle site. Halimbawa, paano kung uy, ang gusto ni team lead hindi times 2 para sa module na to. Sabi daw ni team lead times 3. Times 3 is what team lead wants. And then you have to revise. So the team is issued, oy, pare, we have to revise. If you did it this way, parang you can think of it as you've hard-coded the you've hard-coded the functionality inside the mismong module. And you will have to medyo hassle kasi you have to spend much of your time trying to look inside one function and then trying to debug and change everything. This is a lucky situation because we just need to change one line. But what if it's a very big project and you have to look for all instances? It's gonna be a nightmare. Wala ka ng weekends. Anyway, in order for us to not have that problem, we have to, so hence the concept of generalizing functions. So if we want to generalize, it would mean taking out all of the functions that let me show you what I mean and explain what it is. But the intuition is, I want to take this out. I want to have that capacity, or I want that code flexibility for me to change its behavior without changing anything inside of it. Kasi that's the functional property, diba? Function is a black box. Ang gusto ko lang talaga mangyari sa functional, if I'm designing for a functional language, may input ako, may output ako. That's the only thing you have to tell me. Whatever is inside is not my concern. Kasi nga a function, input, output. The processing is not mine to do. Parang, Alexa, show me photos of bears. That's functional si Alexa, diba? I don't really care how Alexa gets the bears. Basta I know that, Alexa, my input is this command. Give me what I want. Input, output. Functional programming. Mathematics function, 1:1. That's the baseline design principle of the language. So let's generalize. Let's try to generalize. What do I mean? So if in generalizing, let's create a generalized map function. Let's take away this. Ang gusto natin, we want to take this outside. So general map function, sort of the same way. So there's an input list, there's an output list in the form of an accumulator that we just need to spit out once the processing is over, but we want to take out the function. Para may freedom tayo to say, or to change that function to whatever function we would want it to be. If that's the case, if not LL, if we arrive at the point where LL is now null, then we just return A. Else, we can say that we want to return gmap, their generalized map function. And we know that we need to fill out 3 blanks. LL. I know that just like the first implementation, I am at each recursive step, I am now concerned with getting the rest of the elements. How about for the accumulator? I know that if this is my accumulator, I still want it, parang ito lang. So let me copy this. I still want it to process whatever the head value is currently. But instead of hard coding the behavior that I want before including it in the output container, I would want to apply whatever the function I created to it. Apply that function to it first before putting it inside the accumulator. And of course, because the accumulator is a list, again, let's just enlist this value before adding it or appending it to our container. Sorry, walang space. I'm trying to put everything in one line. And here, as our third value, will our function change somewhere at the middle of this recursive step? Hindi naman. The function stays the same hanggang sa matapos yung recursion. So you can just safely copy it here. Hindi naman mangyayari na parang half of the elements minimultiply ko by 2 and then half magiging multiplied by 3. At least not for this example. Okay, now that we have that, I think that's good enough. Sige, let's try to test, because we might have errors that we need to fix. So let's try to use or test the generalized map function. Let's use our original input L, which has 1, 2, 3, 4, 5, and then our accumulator from line 31, accumulator A, and then our function. Meron na ba tayong function dati? Ay, hindi. Gawa na lang natin itong x2. Sige, let's try to babalikan ko to so I write my name so that I know kung saan ko babalikan. Let's try to define x2 to be a unary function. If I have n, it just returns to me n times n. And so x2 yung ilalagay ko dito. We know that it won't print anything yet, but it returns values. But we need to issue a print command so that we can see those values. If I try to interpret this once again, sorry, don't forget your colon. Boop. Okay. x2. Sorry. x2 is I was wondering, hindi siya n times n, sorry. That's your exponent x2 times lang tayo, times 2. All right, let me run this again. There, we have our original L array, L list 1, 2, 3, 4, 5, and then using our generalized map function. Let's have a header here. Print gm. Boop. Save, interpret it once again between gm. Generalized map function. Using the generalized map function, we have 2, 4, 6, 8, 10, which is just the original L list multiplied by 2. Kagandahan nito is because it's generalized, we can do something like, ang gusto ni team lead is you multiply it by 3 and then, hypothetical scenario, and then you add 1 plus 1. Multiply by 3 plus 1. Takes as its parameter a single value, and then you need to return n multiplied by 3 plus 1. No parentheses kasi PEMDAS naman ata. If I try to print this again, gm, same L, same A, but this time, gusto ni team lead, x3, p1. If I try to evaluate that, we get the mapping, pero this time we were able to control the function being applied to the map from outside the function itself, which is pretty nice. So you can imagine that you can work on projects, and then siguro CX2 is assigned to one person, CX3PI is assigned to one person, the mapper is assigned to one person, so that when there are issues with the code, you can technically contact the person who is in charge of that particular module without disrupting the work of the others. This is a very important concept that they have a name for it. It's called higher order programming or functions. Programming kasi in the context of creating a project, higher order programming. Pero functions if you're just taking at the mathematical implementation of it. And it's nothing but it's just referring to, or the mathematical definition of higher order functions are functions that return a function. Yun. Kasi dun sa pag-return niya, meron siyang nire-return na function. Ito pa. Or functions that takes as its parameters at least one function. So that is its design, or higher order programming is the mechanism that functional programming languages have in order for you to create abstractions. And abstractions are cool because in order for the computer to accurately model what's happening outside, it needs to abstract ideas. yun lang. I think the video ends here. I hope that was relatively short. Pero let me just pose a question here now to end this video. And this is one of the questions included in your quests, but I wanted to pose it now just for you to think about it a little bit more before I finally ask the groups to submit. One of the questions is kalimutan ko. Ano ngayon? Is it yes, I remember now. Is it possible to do higher order programming without using tail recursive functions? Yun. So in the first video that I've sent you and in the first few modules, you were looking at tail recursion. Now we're doing higher order programming. So let's combine the Lego. Do you think it's possible to do higher order programming without using tail recursion? If yes, how? If not, why? And I'll end there. Thank you for your attention. I'll upload the same code that you have seen here in this video to our Moodle page, and I'll see you in the next video if we need to create one more. Thank you.